Hi, hello. Welcome to Learn Miss. It's me, Linus. Hope you have watched the last videos. Yes, thank you so much for your support. And in this video, we will be discussing about the previous year questions of SSLC chemistry. Okay. Yes. So let us start with our first question. The order of reactivity of some metals are given. It is already given in this question. Analyze it and answer the following questions. Okay, it's a 4-mark question. So 4 sub questions you can see, and you are given here 4 metals: Mg greater than zinc, greater than iron, greater than copper, greater than silver. 5 metals are given and they are given in the reactivity order. Okay. Yes. Now name any metal. Okay, you can name any metal that cannot displace hydrogen from dilute hydrochloric acid. So that is the question. You have to find one metal from this, okay, that cannot displace hydrogen from dilute hydrochloric acid. So for this type of questions from this chapter, you must know the reactivity series. Okay, so what is the reactivity series? Reactivity series you can see here, starting from potassium, yes, and ending in yes, gold. Okay, potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, then you can see hydrogen. Okay, then copper, mercury, silver, gold. And we know that highly reactive metals, that these top metals are most reactive, and coming down reactivity is decreasing, right? So down the group, coming down the group, reactivity is decreased, and the least one is silver. Gold is having very less reactive metals. Okay, and you can see here hydrogen is placed here in the top of the copper. You can see hydrogen. Okay, so all these metals, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, all these are highly reactive than hydrogen, right? And we know that reactive metal can replace or displace hydrogen from its acid, right? We know that. So reactive metals, more reactive metals, that is the metals which are above hydrogen, more reactive metals, that is metals which are placed above the reactivity, above the hydrogen in the reactivity series. Okay, hydrogen in the reactivity series. Okay, so you must by heart this reactivity series. Okay, reactivity series can displace hydrogen. Okay, displace hydrogen. That means all these metals that are above the hydrogen atom can displace hydrogen, and below copper, mercury, silver, and gold, right? So they are less reactive than hydrogen. They cannot be replaced. Okay, so hydrogen gas cannot be produced from this metal. So you can either say copper or silver. Both are answers. Okay, copper or silver. Any one metal is asked. So you can either write copper or silver. Answer both are correct. Okay. Next question. Which are the metals that can displace iron from FeSO4 solution? Okay. So what is the question? Iron from FeSO4 solutions. Okay. Yes, see iron, right? Where is iron in the reactivity series? Here it is iron, right? Iron in the reactivity series. And we know that the metals that are above iron are more reactive than iron, right? Yes. So these metals are more reactive than iron. So they can displace iron from FeSO4 solution. Okay. So what in this case, iron, more reactive metals are whom? Magnesium and zinc, right? So magnesium and zinc. Okay. Both. Which are the metals? That is the question. Okay. So you have to mention both. So magnesium and zinc, which are more reactive than iron, can displace iron from FeSO4 solution. Okay. Now a galvanic cell is constructed using zinc and iron electrode. Okay. Zinc and iron electrode. We are taking zinc iron electrode. Okay. Then, yeah, which is the anode of this cell? Okay. So whenever we are constructing a galvanic cell, you must remember one thing, that in the case of a galvanic cell, more reactive metal act as what? Act as anode. Okay, that is the thing you have to memorize in your mind. More reactive metal will act as anode. So in this zinc and iron, which is more reactive? Zinc iron, which is more reactive? Zinc, right? So which is the anode of this cell? Zinc is the anode of this cell. Okay, got it. Yes. Now write the equation of chemical reaction taking place at cathode. Let us think about cathode. In cathode, so zinc is reacting as anode, and so iron will be acting as what? Cathode, right? Fe. Yes. Then what is the equation? So in cathode, which reaction is taking place? At cathode, yes, it is always reduction reaction taking place at cathode, and reduction means what? Gain of electrons. Gain of electrons is reduction. So you must know, you must remember the word oil rig. Okay, you must remember the word oil rig. That is, oxidation is loss of electrons, reduction is gain of electrons. Okay, oil rig. Oxidation is loss of electrons, reduction is gain of electrons. And in the case of galvanic cell, we have studied a what we call a word LOAN, loan. Okay, that is left side oxidation, anode is negative. Just memorize that. We have already done a video of galvanic cell. So here you will be given the link in the so just watch that video for the better understanding of the galvanic cell. Okay, yes. So yeah, load. So what is happening at cathode? Just opposite, reduction is happening at cathode. Okay, so what is reduction? Gain of electrons. So what will happen here? Fe2 plus ions will gain 2 electrons and will become Fe. So what is the equation for the chemical reaction taking place at cathode? So no need of studying by heart what is happening in this cell, that cell. So whenever you are asked to write down the chemical reaction at anode and cathode, just think that in anode always oxidation takes place. And oxidation is what? Oxidation is loss of electrons. And reduction is what? Reduction is gain of electrons. Okay. So you can write the reaction according to that. Okay. Yes. Next, moving to the next question. Yes, this question 2NO plus O2 in equilibrium with 2NO2. Okay, and heat. This is, when you see the question, you must understand this is a question from which principle? Le Chatelier's principle. Okay, so Le Chatelier principle. Yes, now let us move to the question. When does a reversible reaction attain equilibrium? So this is a reversible reaction, right? Both forward reaction and backward reaction is taking place. Then when does it attain equilibrium? When does, yes, when the rate of the forward reaction, okay, rate of forward reaction, when it becomes equal to what? Rate of backward reaction, what will happen? They will attain equilibrium. Okay. Yes. Now let us move to the next question. Increase in temperature. So when we increase the temperature, how do the following changes influence the amount of product? Question is very important. Amount of product. So the question is, what is happening to the amount of product? Is it increasing or decreasing? So that is the question. You must understand that. And when you look through this equation or the reaction or the equilibrium reaction, you'll understand that forward reaction is exothermic, right? Because it is releasing heat, right? So forward reaction is what? It is an exothermic reaction, that you understand. Okay. Now, if forward reaction is exothermic, means heat is releasing, right? Heat is releasing here. Heat is releasing in this forward reaction. What happens to the product if you increase the temperature? If you increase the temperature, what will happen? Backward reaction will take place, right? Because backward reaction is endothermic. It is endothermic. Backward reaction is endothermic. So backward reaction will take place if you increase the temperature. Okay. So what will happen to the product? Yes, the product decreases. Product will decrease. Now moving to the next section, increase in pressure. So what is the effect of pressure in this reaction? So to find the effect of pressure to a reaction, 2NO plus O2 in equilibrium with 2NO2, right? 2NO2 plus heat, along with heat. Okay. To find the pressure relation, what you have to do? You have to count down the number of moles in the reactant side and product side. In this reactant side, it is 3 and its product side, it is 2. Okay. So, you have to understand what is happening here, increasing the pressure. Okay. So, just study one sentence. when we increase the pressure, when the pressure is increased, the reaction will proceed in which direction? Proceed in the direction where there is less number of moles. Okay. So increasing the pressure will lead to the reaction where there is less number of moles. Now see, where is less number of moles in this reaction? Yes, here in the product side, right? So when you increase the pressure, increasing the pressure, what will happen? Reaction will proceed in this direction. That means in this case, it will proceed in the forward direction. Okay, you can write forward reaction takes place. But what is the question? What is happening to the amount of product? When the forward reaction takes place, what will happen to the amount of product? Product amount will increase. Okay, increase. That will happen. Understand? So, temperature and pressure is very important. When going to the temperature, you have to check whether where is heat. Heat is in exothermic. So, heat is releasing means exothermic. So, here forward reaction is exothermic. So, low temperature, decrease in temperature favor forward reaction. When you increase the temperature, backward reaction will take place. Okay. Next, third one, NO2 is removed from the system. So what will happen when we remove NO2 from the system? So NO2 is removed means what? Product is removing, right? So that reaction, what will the equilibrium do? What will the system do? System will try to make more product, right? So when you remove the NO2 from the system will try to make more product so that product amount will increase. Okay, so from this topic of Le-Chatelain principle, there will be sure questions for the exam. Okay, like what happens when increase the temperature, when we decrease the temperature, increase the pressure, and something is added, like that. Sure questions will be coming. So just study this topic very clearly. If you want more explanation about this topic, you want me to do a small video of these topics, just comment. Okay, yes. Next, moving to the next question. It is a question from organic chemistry part. A structural formula of an organic compound is given. Okay, so the compound having OR, okay, OR as a functional group is called as, what is that called as? Yes, it is called as, when it comes O and both side are group, right? So it is called as ethers. So they are ethers. So this is a ether. Okay. Find the molecular formula. So finding the molecular formula, just count on the carbon number, hydrogen number, and oxygen number, right? So how many carbon? 3 carbon, C3. How many hydrogen? 3, 4, 5, 6, 7, 8. 8 hydrogen. And how many oxygen? 1 oxygen. So the molecular formula is C3H8O. Then next is write the IUPAC name of this compound. So while writing the IUPAC name of ethers, so you have to count down the number of carbon atom on both sides. So here 1, 2, here 1. Okay. Yes. Then what you have to do? Smaller or shorter alkyl group. Okay. Shorter alkyl group. So which is the shorter one? So this is methyl. This is ethyl group, right? Yes. Shorter alkyl group will behave as alkoxy. So this is methoxy. Okay, that is the point. Shorter or smaller alkyl group becomes alkoxy. The larger or longer one becomes alkane. Okay, so what will be the IUPAC name? Methoxy ethane. Methoxy ethane. Shorter one act as what? Oxy, and the longer one as alkene. Okay, that you have to remember how to write the IUPAC name of this ethers. You have to count down the number of atoms in both sides and count out which is smaller and which is larger. And smaller one write as alkoxy. Okay, and the larger one write as alkane. Alkoxy alkane. Okay, name will be like this: alkoxy alkane. So alkoxy is coming smaller one, and alkane is longer or larger. Okay. Then write the structural formula, the functional isomer of this compound. So what do you mean by functional isomer? But functional isomerism shows by the compounds having different functional group, right? So this is either. Okay, you have to write down C3H8O. Same molecular formula should be there, but different functional group. So ethers and alcohol. Okay, ethers and alcohols share functional isomer, shows functional isomerism. Okay, ethers and alcohols shows functional isomerism. So you just understand that concept. So here it is either, just draw the alcohol with this name. So CH3, CH2, 3 carbon, right? CH2, CH2OH. So counting the number of carbon, hydrogen and oxygen, C3H8 is the molecular formula of this one. Okay, so ethers share functional isomerism with alcohols. Okay, so when you are given either, you can write out its alcohol as its functional isomer. If you are given alcohol, you can write its ether as functional isomer. Okay, yes. Next question. It's also again a question from galvanic cell. Okay, galvanic cell. Picture of galvanic cell is given below, right? So we know galvanic cell contains 2 half cells. Okay, and remember the word again. I am making you to remember the word lawn. Okay, left side. What process will take place? Oxidation always. And anode. A for anode. In oxidation is taking place at anode, and anode is always negative in the case of galvanic cell. Okay, just remember this. Okay, then what is the energy change taking place in a galvanic cell? Very important question. What is the energy change that is taking place in a galvanic cell? So in a galvanic cell, after chemical reaction, electricity is producing. So what you have to write here? Chemical energy will be converting. Yeah, chemical will be converting to what? Electrical energy. Okay, so your chemical reaction will taking place in the half cells. By that you will get electricity here. So chemical energy will be converted to what? Electrical energy. Identify the anode in the given cell. So where is anode? Left side, right? Left is anode. Who is left? Zinc. So zinc is the anode. Okay. Write the chemical equation of the reaction taking place at anode. In anode, what reaction is taking place? Oxidation reaction, right? So oxidation is what? Oxidation is loss of electrons. Okay. Reduction is gain of electrons. Study the word oil rig. Okay. So oxidation is loss of electrons. So at anode, oxidation is taking place. So how will you write the loss of electrons? Yes. Zn gives Zn2 plus 2 electrons. Okay. So in which electrode does oxidation takes place? So when you know this box, this word lawn, it is very simple, right? So when oxidation is taking place at which electrode? Yes, of course, anode. Okay. Yes. Then write the chemical equation for the redox reaction in the cell. Okay. Here zinc sulfate, zinc rod, copper sulfate, copper rod. So we have learned that in anode, oxidation takes place. Oxidation is Zn gives Zn2 plus 2 electrons. Okay. In cathode, what will be the reaction at cathode? Reduction, right? Just opposite reaction. Reduction will be taking place. Here copper Cu2 plus will gain 2 electrons. Gain. Reduction is gain. Cu. Okay. Now you are asked to write down the total chemical reaction. Okay. So Cu2 plus 2 electrons. Cu2 plus 2 electrons. Just erase it. Cu2 plus 2 electrons giving Cu. Okay. Write down the total reaction. How will you write down the total reaction? Just write down this part. Zn plus Cu2 plus 2 electrons gives, and after the arrow Zn2 plus 2 electron plus Cu. 2 electrons are common. Cut it. So what will be the reaction? Zn plus Cu2 plus gives Zn2 plus Cu. So this is the overall reaction taking place in this galvanic cell. Okay, clear. Yes. Now moving to the next question. Atomic number of manganese is 25. Atomic number is given. So write down the subshell electron configuration of Mn. Okay, so you have to beginning. You have to begin from 1s2, 2s2, 2p6. After that 3s2, 3p6. After 3p6, what is the next in energy? 4s, right? And after that 3d is coming. So 3d5, 4s2. So this is the subshell electron configuration of manganese. Find the block of manganese in the periodic table. Oh, last electron is in d orbital, right? So it belongs to d block element. It is a d block element. Which category of elements does Mn belongs? Which category? Is it halogen, noble gas, alkaline earth metal? Yes, it is a transition element because it is in d block. D block elements are called as transition elements. What is the oxidation number of Mn in MnO2? And it is given MnO2 and oxygen is given that -2, right? And Mn you don't know, put at X. There are two oxygen atoms, right? So X plus -2 times 2 is equal to 0. Total will be MnO2 total will be 0, right? So X will be what? 2 times 2, 4, -4. When we take -4 to the next side, you will be getting X is equal to +4. So oxidation number of Mn is +4. Write the subshell electronic configuration of Mn2 plus. So when Mn2 plus means 2 electron has lost, right? So 2 electrons will be lost from the last shell. What is the last shell? Final shell is fourth shell, right? So what will be the electronic configuration of Mn2 plus? Yes, 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. Highest energy is 4s. So electrons from that will be removed. Okay. Yes. Moving to the next question. Yes. Yeah, this is the organic chemistry question. How many carbon atoms are there in the longest chain of this carbon atom? So you have to find the longest carbon chain, right? Yes. You have to number from here 1, 2, 3, 4, 5. So how many carbon atoms are in the longest chain? Yes, 5 carbon atom, right? No doubt, right? Yes. Then what is the next question? Give the name of the branch. So when you go through the branch, you will understand that it is having one carbon. So it is a methyl branch. So the name of the branch will be methyl. Okay. What is the position number of the branch? The branch should get the lowest position number, right? So its position number here is 2. So write the IUPAC name of the compound. So IUPAC name of the compound will be, how will you write? First you have to write the position of the branch, hyphen, name of the branch, methyl, and 5 carbon atom. It's an alkane, right? 2-methyl pentane. 2-methyl pentane. Okay, 2-methyl pentane is the name of this. Okay, next question is hematite. It's a question from extraction of iron in the blast furnace, and we have already done a video of extraction of iron. Please go through the video. Complete information in detail is explained in that video. Okay, if you like the video, please like, share, and subscribe our channel and share to your friends also. Okay, those who are struggling with extraction of iron. Yes. So first question is write the molecular formula of hematite. So what is the molecular formula of hematite? Yes, it is Fe2O3. Fe2O3. And which substance acts as a reducing agent in this process? So we have gone through the extraction 5 steps. In that steps, carbon monoxide, we have studied carbon monoxide is acting as the reducing agent that will abstract oxygen from this iron. Okay, carbon monoxide is a reducing agent. Molten iron is produced along with slag from the furnace. What is mean by slag? Simple question. What is slag? It is just a mixture. It's a mixture of flux and gangue. Okay. Flux and gangue. Slag is a mixture of flux and gangue. And what is this gangue? Is the impurity that is present in the ore. And flux we are getting by the decomposition of calcium carbonate. Okay, we are getting the flux in this process as calcium oxide, and the gang is SiO2, and you have to write down the chemical equation. Okay, so write down the chemical equation. CaO plus SiO2 gives what? Just add it, everything. Okay, CaSiO3. What is this? This is calcium silicate. Calcium silicate. Okay, very important. Extraction of iron in blast furnace. So, sure questions will be coming. So question will be coming like, what is the need of this flux, how it is prepared, and which is the gang here, and what is the chemical equation here, formation of the slag and reducing agent. Like that questions will be one mark questions will be coming. Okay, just please watch the previous video. Okay, yes. I'm moving to the last question. Atoms of elements A and B contain 3 shells each. Okay, 3 shells. That means they belongs to, 3 shell means third period. Okay, whatever information we get, we have to add. Okay, A belongs to group 2 and B belongs to group 16. Yes. Now you are asked to write down the subshell electron configuration of A and what is the valency of B and chemical formula. Okay, yes. Subshell electron configuration of A. What is A? A belongs to group 2 and third, 3 shells mean third period, right? Group 2 and third period. Okay, so its electronic configuration will be what? 1s2, 1s2, 2s2, third period. So, and second group means second group means yes or yes, right? Yes block. 1s2, 2s2, 2p6, 3s2. So that means it belongs to what? Third period and second group S2 electrons. Okay. What is the valency of B? B means what? Group number 16. Group number 16 is having a valency of, because it needs 2 more electrons, right? So its valency will be 2. And what is the chemical formula? So both A can donate 2 electrons. When you write the main electron configuration of this one, you will write like, what is atomic number here? Yes, 12, right? It's atomic number 12. Atomic number 12 for A. And what is atomic number of B? B is when we 3 shells and group 16, right? So 1s2, 2s2, 2p6, 3s2, 3p, 4, 3p4, right? Yes, so it belongs to what? 16th group, 3p4. Yeah, so its electron configuration is, atomic number is 6, 7, 8, 9, 10, 14, 15, 16. It needs 2 more electrons to complete the octet. That is, its electron configuration will be 2, 8, 6. Okay, 2, 8, 6, 2 more electrons, and this one will donate 2 electrons because its electron configuration is 2, 8, 2. Okay, so A will donate 2 electrons, B will accept 2 electrons. So A will donate, its valency is 2, and B is also having valency 2. Then just proceed, you will be getting A2, B2, same thing. So its chemical formula will be AB. So in this type of questions, what you guys have to do is, you have to just write down electron configuration, main shell electron configuration. You will get easily the chemical formula. Okay, try to find out the main shell electron configuration. Okay, so you'll get the, first you want to find the atomic number for that, right? Then only you will get the main shell electron configuration, so that it is very easy to find the valency, so that you can easily find the chemical formula. Okay, so hope you like the video. Kindly share to your friends, those who are struggling with the chemistry topics in SSLC. Okay, so all the very best for your exams. Okay, kindly share, subscribe our channel. If you want more videos, just comment it. Okay, then bye, see you, thank you, see you on the next video.